Hello and welcome to the Geostatistics course for beginners with QGIS and R. This is the third lesson of this course and the topic for today is going to be univariate analysis. To start, I would like to show you the kind of graphs that we can create with QGIS and also R. I'm going to use the data we downloaded the other day. If you missed that video, you can hit the card located at the top right corner of your screen that is related with the second lesson. I am going to show you with the groundwater and data set. Open, and we talked about all these parameters the other day. I'm going to pass this one faster. Then I'm going to close this one. I'm going to add also the Google satellite imagery to give the points of information some geographical context. And I'm going to change also the color of the dots because it's going to be better. Now it's very hard to see them. For our red color, apply and OK. In this layer of information, we have an attribute table with 4 parameters. X and Y are the UTM coordinates. GW is the groundwater elevation and it is in meters, and the fourth column is related with the number of piezometer. This is a groundwater monitoring wells. Then as you can see, this file, it's a CSV and we can use this one, or also we can use a shapefile. The other day I exported the information in a shapefile, but you also can use this kind of format. Then what we are going to do now is to see what kind of graphs we can create with QGIS and R. It's going to be a small example, because I know the creation of the algorithms could be the most attractive part of this course, and I'm going to leave this part for the end of the lesson. First, I would like to show you some slides, but now I would like to introduce with a few examples of the graphs. First, I'm going to show you how to create a very simple graph. Histogram. We have to add here the parameter we want to analyze and also the layer. As there is just one layer of information, it loads automatically. But if you have different layers, you can select the layer you want to analyze. Then select the parameter. In this case, it's going to be groundwater. And then you have also the option to save the image of the graph in a folder. We are not going to use this option at the moment. Then just press the button run. Leave the algorithm do its work, and then it's already created. Then we can see, and as you can see, this histogram, it's pretty simple. By default, the software gives us 30 bins. In this case is even too much, and we have some labels, but we cannot see too much information. Count, layer parameter. We can improve that graph, and that's the amazing thing that you can do with R. And I'm going to show you now the second one, where we have a histogram that is customized. Then I'm going to open this option again, select the layer. We have just one layer. Select the parameter you want to analyze, groundwater. In this case, we are going to add 8 bins, and as you can see here, we can add the labels. For the X, I'm going to add groundwater elevation in meters. For the Y, I'm going to add the frequency. For the title of the graph, I'm going to say that it is a histogram. And for the subtitle, I'm going to add raw data. I like to add subtitles because sometimes you have to modify your data and you want to say that information on the graph. As this graph is not going to show any modified data, I'm going to add raw data. And I'm not going to save the file, then just press run. And that's the second graph we have. And as you can see here, everything can be customized. The number of bins, the letters you are using for the labels, are the axes, the color of the title, color of the bins, everything can be changed in this graph. As you can see, the difference between this one and this one, it's a lot. Also, you can add some statistics on the top of the graphics. That's what we are going to do now. I'm going to show you with the number 3, where we are going to show on the graph the mean and the median. Is going to be for groundwater. The number of bins in this case is going to be 10. Going to change, and the labels are going to be the same. Then I'm going to copy and paste, then run. Let's see, and now we have this graph. I changed the color of the bins also, and added some legend over here. The lines are related with the mean and median, and that's pretty interesting, right? You have the histogram with some statistics on the top. Now I would like to show you the last example. It is going to be the number 4, where we are going to add the cumulative distribution function. That is very important for the geostatistics, and I'm going to show you now groundwater. The label in this case is going to be the same. Copy for the groundwater, but for the Y is going to be the probability. For the title of the graph is going to be the cumulative distribution function. And for the subtitle is going to be histogram, because it is a histogram. Then run. And we have the graph over here. And that's amazing. You see, now we have the title here, the histogram, we have the legend indicating that this line is related with the groundwater, we have the probability here, and the most interesting thing is that we created all these graphs just with a few clicks. And that's the most interesting thing, right? Because you are not going to lose some time developing again the scripts. Once you have your scripts done, you can use that scripts for any project. Then what you are going to do is load the data of information on QGIS, and then you can do the exploratory data analysis using QGIS, and that's pretty amazing, right? Then today we are going to see how to create some of these scripts, but as I said previously, that is the most attractive part of the course. Then I'm going to leave that one for the end of the lesson. Now I would like to show you some slides related to some definitions on geostatistics. As you know, this course is not only related to the creation of scripts for being using with QGIS, it's also to explain the fundamentals, the basics of the geostatistics. Okay, let's go to move on to the slides. The first question that we have to answer is why exploratory data analysis, EDA, is essential for any data science project. And here we have just 5 reasons, but I'm pretty sure there are more. But I decided to pick up that 5 reasons because I believe are the most important ones. Then exploratory data analysis is going to help us on the detection of mistakes in our samples or in the measurements that we are taking from a specific variable. And mistakes are pretty normal. This is something really common. You know, people go to the field, you know, the technician is taking some measurements and then they write a wrong number. That is pretty normal. And also can happen that the instrumentation that is using to taking a measurement of something doesn't work properly. Or maybe the calibration of that instrument, it was not good and they are providing wrong values. That is something that happens, you know. And also, for example, the lab can provide you a wrong concentration related with a heavy metal. That things are pretty normal and you have to be ready to detect that kind of values in your data and then treat that one as errors or mistakes. Also, for example, the exploratory data analysis can help us on the evaluation of missing data. For example, we go to the field, we take some samples, Then we try to make a model with the values of that samples in the variables. And then what we saw is that our model is really weak because there are some area on the side that we want to analyze that we are missing some data. Then to identify that kind of problems in your data is very important, because in that way you can make strong models. Then you can go to the field again and pick up more samples, for example. And that it's essential, right, to have strong models. Other very important thing is related with the detection of outliers. Outliers is values in our parameters that are pretty different than the rest of the population, and sometimes they are treated like mistakes or errors, but other times that is not true. Maybe other times that is the most important information in your data, because maybe that data is related with the focus of contamination, for example in a contaminated soil, or maybe it's the part of the mine where the concentration of gold is the highest one, and then you want to explode that area. Maybe it's values that represent something that we didn't take enough samples to have a bigger representation. Then outliers, it is very important, and we have to identify them, and we have to treat them as outliers and take the maximum information from them. It doesn't mean that we have to remove from our data. That's not true. What we have to do is treat them as outliers and extract the maximum information. And with exploratory data analysis, there are a lot of statistics techniques that we can use to identify them. Pretty easy, and that's really good. Also, another very important aspect is the relation between the variables. That is very interesting. We are not going to see that one in a univariant analysis, but we can see that one in a bivariant analysis and also multivariant analysis. And let me put an example. If we are doing a model that is related with the groundwater flow direction, we want to know what is the relation between the direction of the groundwater and the X and Y coordinates to see if there is any trend. And we want to remove that trend from our data in order to use specific models that require that circumstance, right? Remove the data. I mean, remove the trend from the data. And with this kind of analysis, the exploratory data analysis, we are going to identify that kind of trends, patterns, pretty easy, pretty fast, and that is a very strong tool. Also, the last one, and no, it's no less important, it's related with the assumptions. When we are trying to create some models, we are using statistics methodologies, right, or statistics techniques, that there are some assumptions. If we are not covering that assumptions, we cannot use that methodologies. Then we want to make sure that our data it's covering that assumptions in order to use any specific techniques or statistics methods to create our models. And that's also really, really important thing, right? Now let's go to move on to the next slide. This one is a small definition about univariant analysis. The univariant analysis is the most simple way of analyzing data. Unique means one, then what we are going to analyze is just one variable. In this context, we cannot talk about geostatistics with just one variable, as we cannot provide any spatial information like the coordinates for the location of our data. Therefore, it is more adequate to talk about statistics, just statistics, when we are doing univariant analysis, instead of talking about geostatistics. This definition makes a lot of sense if we are talking about defective pieces of metal in a factory, right? For example, if we are doing a statistic study about this kind of pieces. because over there is no any spatial component, right, in that kind of statistic studies. But when we are talking about geoscience and we are measuring variables that are related with the geoscience, most of the time that variables has associated UTM coordinates, and sometimes it is pretty difficult to think in that kind of variables as variables that don't have any spatial component. However, when we are working with univariate analysis, we are using just one parameter. For example, if we are doing the analysis of soil concentration in arsenic, for example, what we are going to have is just the concentration of arsenic. We are not looking on the coordinates. We are analyzing specifically the concentration, and that's a univariate analysis. Now let's see how to create some scripts with R using QGIS. Now I am going to load the data related to the groundwater, the data set, then go vector, here select the file. We created this file the other day. It's going to be groundwater shapefile, open, add, close. Then as we did previously, I'm going to add the satellite imagery to give some context. And I'm going to change the color of this one. That one is a shapefile, as you can see in the information. Over here, storage, shapefile. I'm going to change the color of the docs. Symbology for a red color to see that one's better, or orange. Apply and OK. Now we are going to create the first script. Then to do that one, we are going to go here. If you don't have this script, you have to go to Processing, Toolbox, and select that one in order to open that windows. Okay, this one. Then go to, we are going to use also another one that is going to go the viewer results. Then go to View, Panels, and here select Results Viewer. And we are not going to use this one. I'm going to adjust this one a little bit, like this one. Then go to R and create new script. And then I'm going to copy and paste the script. Copy and paste. And now we are going to see a little bit the structure of this one. I'm going to make this one bigger to see a bit better. Okay, at the moment I'm going to leave like that. The first thing is we have to indicate the software where we want to storage this script. And then what I'm going to add is this name to this group. Okay, and the groups are these ones. When you go to here to R, this one is a group, this one is a group, and what we are going to add here is a group that is going to be called R and QGIS course. The second one is to save the information that we are going to get in the script as an image, and also to see the result here. That's what this one is indicating. The next one is related to what kind of format has the file that we are going to use to analyze our parameter. In this case, it's going to be a vector layer. It's going to be this layer. This layer is a vector one. Properties, I don't know if we can see that information here. Well, we know it's a shapefile, right? A shapefile, it's a vector layer, right? Then that's it. Then the other one, for example, if we are going to take the data from a raster layer, we have to change this one for a raster. But we are going to see that one, these kind of things later, maybe in a different lesson. And the last one is for how we identify the parameter that we are going to use. Okay, that indicates that it's constant. It's going to be always the same name, but here you have to add the name of the parameter you want to analyze. Maybe now it's a little bit confusing, but you are going to see that one better later. Then this one is related with the library that we want to load on R to do our analysis or our script. In this case, I'm going to use the ggplot2, the library ggplot2. With this kind of library, we can make a very nice graphs, and there are a lot of possibilities for the customization of the graphs. Then this one is the script. For this script, we want to analyze this parameter. And this parameter is not specified yet. What I am saying is this parameter is this one here. And it's the parameter that is going to be shown on my interface. I'm going to show you the interface. If we click here, we are going to see the interface, okay? Then here, as we said previously, I don't know if we can see both of them. Yes, at the same time, okay? Here and here. Oh, sorry. Here and here. Okay? For the layer, is this section, okay? This section. We are saying that in this section, we are going to add a vectorial layer. As we put here, vector is this layer here, because we are working with vectorial layers, that is a shapefile. Then for the parameter is this one, parameter, and is this information. If you change the name here for a variable, here you are going to see variable, okay? Then what parameter I'm going to add? From the vectorial layer, this layer, I can add all these parameters. But the one I want to analyze is the groundwater. Then I'm going to select groundwater, right? Then we know already that we are going to use that library. And now for the show plots, is this option here allows us to save the result in a PNG format for the image, and also we can see the result in our browser over here. Then this one is the script, and as I said previously, and that's the parameter we want to analyze. With all this sentence, we are saying that our parameter is from this vectorial layer and for a specific parameter that we are going to select. Has to be like this, okay? That's very important. And also for the next section of the script, we are saying that we want a histogram. Then we are going to save that one. Click here, save as. Then select this folder. Remember that this folder, I'm going to show you here. I'm going to close this one at the moment. Okay, I cannot close this one because I have this one open. I'm going to close this one, and I'm going to show you that folder, okay, because that is important. Go to settings, options, and when you go to providers, R, here is the folder where we are going to save all our scripts, okay? And that's very important. And when you try to save, it link to this folder, okay? The software link to this folder directly. You don't have to look for this folder. Then go here, sorry. I close the, okay, I close the script. Then create new script. Going to copy. Paste over here. And I'm going to save, and this one is going to be save the first histogram, and I'm going to add simple, then save, and we can close this one. And as you can see now, when we go to the R, we can see that this group has been added. Okay, over here, that's the group we created, and if you open that group, you are going to see that we have our script over here. Then if you want to run the script, just double click And as I show you at the beginning, then you can load the layer you want to analyze, then select the parameter. In this case, it's going to be groundwater, and we can save the result. I'm going to save to the file, and I'm going to select this folder. Here, select the format you want. I'm not sure why I cannot save in a different format, but let me leave this one at the moment. Let's see what happened. And one histogram. Save and run. Now it's going to take a long time because the software is going to install a lot of libraries. Okay, and the first script you are going to run is going to take a lot of time. Okay, because it's downloading a lot of information from this direction over here that you can see over here. Sorry, this one over here is taking a lot of information from that web. Then I'm going to pass the video faster. It took around 7 minutes, and what I saw is that the software installed a lot of packages, and that's really good because previously I was thinking that I have to install the packages in R, but what I saw is QGIS from these windows, they are installing all the packages, and that's really nice. Then we can close. Well, let's go to leave open these windows and double click here, and we have to select a browser we want to use to open the graphs. I'm going to use Firefox. Okay, and we have the graph here as we saw previously, and also I would like to see if it is safe as a picture over here. Okay, as you can see here, if we open this one, properties, that is a PNG, and it's an image, and we have the graph right there, and that's pretty good because you can copy from here and paste on your report. Okay, let's go to again here, and now let's go to move on to create the next script. Okay, in this case we are going to add some modifications. Then we are going to create this one. I'm going to paste over here. I'm going to make this one bigger, but I want to compare with the other one that we created. Then to do that one, just go here, click right on your mouse, and then press here edit script. And now we can see both of them. Let me show you the other one. Okay, I'm going to put this one here and this one next to this one. As you can see, the number 1, number 2, number 3, and number 4 is the same as before, but now we added a new thing on the interface. That is going to be the number of pins. The library is the same. Also, the first part of the script, let me put this one down over there. The first part of the script is even the same, but at the second part, as you can see here, we adding some things as the number of bins, and also we started to modify some things on the graph as the color, the color also for the fill, and the transparency of the graph. Here you can play with these numbers to change the color of the fill, the stroke of the lines, the transparency. Then let's go to save this one as a histogram simple 2. Histogram, this one, number 2 is going to be, and here is going to be number 2. Then save, Close, close, and let's go to run that one. This one here, number 2, double click. Then as you can see now, we have a new section that is number of bins. The layer is still the same. The parameter we are going to analyze is groundwater. And we are going to add 10 bins, and we are going to save at the same folder as before. But now I am going to put here with bins and save and run. This process now is going to be faster because we have already all the packages and also all the libraries downloaded. The packages and the libraries are already loaded. Okay, close this one, double click here to see the graph, and it's this one. Also, if we go to the folder, we are going to see that is that one, and we can open, and that's the graph we get. Okay, now we add 10 bins, and we have some modifications. If you compare with the other one, we added some color over here, and also for the fill, and also the number of bins. Now we can go one step further and make a little bit more customized our histogram. Now what we are going to add is some labels in our graph. Then create new script. I'm going to paste over here. I'm going to make this one bigger, and I'm going to make this one easier. Then I'm going to go with this one down, and also with the other one. And let's go to compare with the previous one. Is this one. Edit the script, make this one bigger, perfect. Select the other one, and as you can see here again, we have from 1 to 5 is the same as the one we did before, but now we are adding the labels. Label for X, label for Y, also the title of the graph, and also a subtitle. As you can see here, we put the character that we are going to use. In this case is a string, but before for the number of bin it was a number, real number. And the library is going to be the same. This one is still the same. Let me make this one bigger. This one is still the same also, but if we want, we can change the color. For example, for number 7 here, or number 6, and also we can change the color of this one for number 3, for example, to see how it changed. And now I added a new thing that is related with the labels, and is this new section. I'm going to make this one bigger. Is this new section where we are saying that for X we want this label, that is this one here. For Y we want this label, and is this label here, and is the label that we are going to add on the interface, right? And for the title is going to be this one, and for the subtitle is going to be this one. Then let's go to save this one as a histogram simple 3. Number 3 here, and let's see what happened. Also number 3 here. Save, close, and let's go to run this one. I'm going to close this one also. This group here, number 3, execute. Then we can add the information. The layer, we have just one layer. The parameter is going to be this one. The number of bins is going to be 8 number of bins. And for the labels are going to add here groundwater in meters, groundwater elevation. Then for the Y is going to be the frequency. For the title is going to be histogram. And for subtitle is going to be raw data. And I'm not going to save now. Also, we are going to see that one later in a different lesson, but here you can add help to fill all these fields over here. That ones are pretty directly, and it doesn't make any sense to provide information. But if you want to provide information, I'm going to show you how you can provide this information in this screen, because sometimes the algorithms could be very complex to fill the information here, and you can add some notes here to help the people to fill this information properly. For example, if you send this script to other person, that notes over here are going to be very interesting. Okay, let's go to run this one. We have already the graph. As you can see now, if you compare with the other one, we changed a lot of things. The color of the beans, the color of the line, the transparency is still the same. And we add the title here, and also here and here. That is the difference if we compare with the other one. That one, it comes by default, but this one is the labels that we want for this graph. Now let's go one step further in the customization of the graph. In this new script, I'm going to show you how you can edit the labels. Then I'm going to create a new one, and I'm going to paste over here, and I'm also to open the number 3 to compare, edit, make this one bigger. Over here, going to bring the other one, going to put over here. I'm going to make this one bigger, and as you can see, there are not too much differences, because the options over here are the same as these ones over here. But in this case, what we added is all these 3 sections. With these three sections, we can edit the labels. As you can see, theme, plot title. With this one, we can modify the characters of the letters at the title, the size, the color, etc. With this one, for the axis, okay, we can edit the labels in the axis for the color, the size, everything. And for this one is related with the subtitle. And the editions we can do, it's a lot. In this case, I put these 3 as an example. Then I'm going to put the same color here as the other one is 6, and this one is going to be number 3. Then we can compare the result. I'm going to save this one as a histogram simple 3, sorry. Sorry, it's going to be 4. 4 here and 4 here, and save. Let's go to close this one, and let's go to run the script. Then go here, number 4, execute, and groundwater is going to be 8 beans. And I'm going to put the labels here, but I'm going to pass the video faster. Also, I'm now going to save the graph, and I'm going to run right away. And then double click to see the graph. And as you can see, now we have the title at the middle of the graph, and we have that one in blue color, and also for the subtitle, and we have here the frequency, and we make some additions. If you compare, you are going to see the differences. Here, as I'm seeing now, there is no addition for the letters. The addition is related with the numbers. Okay, but you can add more things to make the addition of these ones if you want. Well, the video is pretty long, but I would like to tell you that if you want to get the scripts, you can get that scripts at the Geo RGB community website. If you go to courses, then select this course, then start the course, go to the lesson. It's going to be lesson 3. And then when you go to the bottom of the page, you are going to be a section like this one. That's for lesson 2, but you are going to have the same for lesson 3, where you can download the scripts. I'm going to put the scripts just at the website. Also, if you have any question, you can go here for the lesson 3 and add your question, and I'm going to be the only one that is going to see the question. But if you want to be more active and you have more general questions, or if you want to add anything to the course, you can go to groups, and I created a forum for this course. Is this one. We have already 2 members, and if you want to introduce something more general related to QGIS and R, you can be a member of this forum and add whatever you want, right? It's something that allows the members to participate actively in this course. Also, I would like to tell you that I'm going to give priority to the questions that are posted on the website, and the YouTube questions are going to be the last ones to be answered. Okay. Well, thank you very much for watching, and see you on the next video.